Hi, welcome to Avocet Math. In this video we're going to look at another problem from our set of AMC10 counting problems, and let's see what we have. 3 tiles are marked X and 2 other tiles are marked O, and the 5 tiles are randomly arranged in a row. What is the probability that the arrangement reads XO, XO, X? Now in the AMC, we can calculate almost all probability questions using a simple ratio formula where we compute the probability as the ratio of the number of event outcomes that match the condition we're interested in divided by the total number of outcomes. And as long as we take a little care to make sure that the outcomes that we're calculating are all equiprobable, then this formula works quite well. And let's see how we can apply this to this problem. So in this case, we have these 5 tiles marked XO, XO, and X. And one of the difficulties with this problem is that the X tiles seem to be indistinguishable, and that sort of makes the probability difficult to calculate. So this is one of the problems where, even though the X tiles seem indistinguishable, it's important to put a label on the tiles so that we can recognize that the tiles themselves are distinct. So in this case, I put the labels 1, 2, and 3 on the X tiles, and the labels A and B on the O tiles. So now we're ready to calculate one of the terms in our probability ratio, the total number of outcomes. And what we notice is that the total possible number of arrangements of these 5 tiles is very similar, in fact identical, to the problem in which we give you the numbers, say 1, 2, 3, 4, 5, and we ask you to come up with the total number of arrangements of those 5 numbers. So we have 5 distinct numbers, here we have 5 distinct tiles, and as we know, the total number of arrangements for these 5 distinct objects is 5 factorial. So that's in fact the denominator of our probability expression. And now comes the task of counting the number of possible ways that the O's and the X's can be distributed within this particular arrangement. So in this case, we're calling the event outcomes of interest the possible ways that we can arrange the X tiles and the O tiles such that they form this pattern XO, XO, X. So let's take a look at the O tiles first. We notice that the O tiles basically have to fall into positions 2 and 3 in our ordered row, but we also see that there's a possibility for the A tile to occur first or the B tile to occur first. So essentially they can be swapped, and that's similar to a permutation arrangement of 2 objects. So in essence, the O's can be arranged in 2 factorial ways. Likewise, we see that the X's have to occur in positions 1, 3, and 5, but since they're essentially physically 3 distinct tiles, they just happen to have the same X marking on them, we see that the X's can be rearranged in 6 possible ways corresponding to the permutations of 3 objects being 3 factorial. And now we reach another critical point in these counting problems. We have to decide whether our arrangement of the O's is in fact independent of the arrangement of the X's. So in this case, since the O's can only occupy positions 2 and 4, and the X's can only occupy positions 1, 3, and 5, and they are in fact distinct objects, we see that there's really no connection between our choices of the O's and our choices of the X's. So the total number of ways that we can choose the X's and the O's is just the multiplication of the number of ways that we can choose the O's and the number of ways that we can choose the X's. They're essentially a compound set, and we can use the multiplication principle for these compound sets to compute the total number of ways that the X's and O's can be arranged as the product of 2 factorial times 3 factorial. And then we can use some simple factorial algebra to recognize that the 5 factorial is basically 5 times 4 times 3 factorial, and this simplifies to 2 factorial divided by 5 times 4, or 1 times 2 divided by 5 times 4, which reduces to 1 over 10, and that is choice B. Anyway, this is not quite the same way that the problem was described in the published solution, but I just wanted to point this out that you can use this basic ratio formula for almost all AMC probability questions. And hope that was clear, and we'll see you in the next video. Bye.